Approximately 17,500 years ago, a powerful volcanic explosion occurred in the Arctic of far western Alaska, releasing energy equivalent to the detonation of more than 2 million tons of TNT. As 9.7 billion tons of rock was pulverized through a phreatomagmatic explosion, a towering eruption column was generated, rising up to an altitude of likely 120,000 feet. Then, due to part of the erupted material in the plume being too dense to rise on a buoyant column of hot air, it collapsed back to the ground, incinerating several hundred-foot-high pyroclastic flows. These incinerated everything in a 5.5-mile radius, traveling to and entering the ocean 13.7 miles to the north. By the time this eruption had ended, a raised rim up to 100 feet high had been created surrounding the newly formed crater, which measured 5 miles long. While this is interesting, what is even more intriguing is the fact that this eruption brought up not just surrounding rock and some lava, but also material which had long ago been buried in the subsurface. Specifically, fossilized mollusks, in this case presumably snails, and petrified wood, the latter of which is common enough in the eruption deposit that it indicates a dense forest was once situated here. And yet, we are talking about a tens of millions or more than 100 petrified wood million-year-old fossil, but rather one which is estimated to be between 115,000 and 345,000 years old. This is quite strange, as if you look around the currently permafrost-filled essentially barren landscape, there are only grasses and occasional shrubs, with the exception of a heavily stunted tree or two along the edges of the largest of the region's lakes. How could this be possible, as it is accepted that the planet is today much warmer than it was during the Ice Age, which began 2.58 million years ago? The answer is that, contrary to popular belief, there were actually Pleistocene period times during the Pleistocene epoch, aka the period which saw repeated widespread glaciations, where our planet was actually warmer, not colder, than it is today. This several million-year-long timeframe did not consist of a single continuous glaciation which reached all the way to New Jersey, representing a period of continuous widespread glaciations, but instead dozens of glacial and interglacial periods. For example, during the Pleistocene's last interglacial period, which lasted between 115,000 and 130,000 years ago, average world temperatures were 3 degrees Celsius or 5.4 degrees Fahrenheit warmer than they are today, with this figure being twice that amount within the Seward Peninsula. This means that during that interglacial period, termed the Eemian, what is today the barren tundra of the Seward Peninsula was more like that of today's Sitka, heaving forested a whopping 1,000 kilometers or 621 miles further south. The reason I am mentioning this period is that the Eemian seems to represent the warmest such interglacial